Morning, ladies and gentlemen. This is Mr. Green. I am recording another lesson for you. I just wanted to make certain you got this lesson. This is AP Statistics, and we're going to be talking about uh, some things that deal with Lesson 4.2, Study 1. Now, we've already defined some of these terms, but I want to make certain we go over them just for a little bit. A population, that's everybody that's going to be counted, okay? It's everything that fits within the category that's going to be counted. An observation, that's when you're looking at something, you're not really changing it any, but you're just looking at it and collecting some data about it. A unit of analysis, well, that's just one person that you've talked to, one thing that you've talked to. So that's just the unit of analysis. A variable is something that could cause the data to be changed one way or another. Okay? And so what you're trying to do is you're trying to control most of the variables, but see what the effect is on one of the variables. A constant is something that doesn't change. And values are numbers. Those are things that you know that exist out there, different values that exist, okay? So, distributions. Every variable has a distribution. What does a distribution mean? Well, if I'm talking about a variable, it's telling you how is that information spread out. Okay? What is the range of it? What is the height of it? What does it look like? What values does it take and how often does it take those values? Typically, we show a distribution in a graphical form. There are a number of observations that you can take of each value of a variable, and that will tell you the frequency that it occurs. Okay? And you can use that frequency information to make the graph. Okay? You've all seen these type of graphs before. This is a frequency distribution graph. Okay? This is showing the distribution of the number of siblings. So if you only have one brother or sister, you'd be in this category. If you had four, you'd be out here in this one. If you had eight, you'd be out here in this one. If you were the Duggars, you'd be off the chart. So it's a matter of just looking at where do you fit in this particular range. Okay? Now you can see that three siblings, typically we've got 8 people that have those 3 siblings. And 5 siblings, you've got 4 people that have 4 siblings. That doesn't mean this is a perfect distribution for you or for everyone in this class, but over the people that they were surveying, this was the distribution of the number of siblings that they had. Okay? So, what are the most common graphs? You can have histograms. That's just what you were just looking at. You could have bar graphs that look very similar to a histogram, but they're not measuring how many times the frequency something occurs. Might be measuring something different than that. You could have dot plots, which are just spots on the thing. You could have scatter plots that are scattered all over the place. You could have line graphs. There's hundreds of different types of graphs out there that you could have, okay? So let's start with a table of data and just start looking at the way some of these are put together. So looking at this information right here, what we're looking at is there are many ways to measure the reading ability of children. One frequently used is the degree reading power, or DRP. In research study on third grade students, the DRP was administered to 20 students, and these were their scores. What are we going to do with these scores? Maybe we ought to put them into a histogram. Okay? Well, the easy way to do that is to order the data from the smallest to the largest. So I just rearranged that table that I just had there and put it in this order. So smallest number up here, get my pointer so that you can see what's going on. Smallest number right there, largest number back over here, just arranged it this way. Okay? So then they're saying to choose class boundaries. Well, what would be a class boundary in this situation? Well, maybe one of the things we could use as a class boundary would be from 14 to 25, and from 26 to 33, and from 34 to 35, and from 35 to 42. If we did that, we would see 4 in each one of our categories. But because our data down here, our ranges for each one of these different classes wouldn't have been the same, it wouldn't have really told us much, would it? So one of the easier things to do is to look at, well, we go from 14 to 52. Let's see here. 52 minus 14. I'm really bad at math when I'm put under the pressure like this. 52 minus 14 gives me 38. If I wanted to have 5 categories, I divide that by 5, and that would say 7.6 in each category. Well, that's not an even number, and these are all in whole numbers. Maybe we want to do something different than that. 38 divided by 6. Well, that's still not a whole number. That's 6.33. 38 divided by 7. Nope, not a whole number. 38 divided by 4? 9.5. Well, that looks like it might be what we're going to wind up with. If I divide it by 4, I'll just wind up with 5 in each one of them. I don't know. Let's see what they came up with as their class boundaries. Yep, they're not saying. So what they did is they chose class boundaries. They found the midpoint of each of the intervals that they're looking at, and then they made their histogram and drew their label and axis. Horizontal intervals, vertical frequencies. So let's see what did they do it for us here? No, they didn't do it for us here. So let's show you what I'm going to do. I'm going to show you the way I do this on a calculator. Calculator? Ms. Green, we can do it on our TI-83 calculator, 84 calculators here. Yes, we can do it on our TI-84 calculators. You're going to have to excuse me while I move something around so I can see it while I'm keying the numbers into the calculator. Here, cool. What I'm going to do is I'm going to press Stat, and it's going to bring up this little thing right here, and I'm going to say Edit. I'm going to hit Enter for going into Edit. What I'm going to do is I'm going to enter this information into one of the lists here. I'm going to enter it into list 1. So it's 14, 19, 22, 20. Geez, I made it too small. I can't read it. Excuse me while I make it bigger so that I can read my own data. Here we are. 22, 25, 26, 26, 33, 33, 34, 35, 35, 35, 35, 39, 40, 42, 47, 47, 48, 52. Yes, you can tell I'm a key punch person. Okay, so I've entered that data in there. How many data points do I have? Well, its next one is going to be number 21 here. That must mean I've got 20 data points entered in here, and that's how many were on our screen. Okay, so what am I going to do next? I'm going to come up here and press second y equals, because I want to create a plot. Okay, so I'm going to go into plot 1 here. Do you see this one right here? That is a histogram. So I'm going to say on, and I'm going to come down to that and go over to histogram and select histogram, and I want to use L1 as my data. And when I press graph or enter to get that all in there and hit graph, it didn't like it. Why didn't it like it? It's using L1 and L2. Why is it using L1 and L2? It's supposed to for a histogram. See if it'll do this for me. L1 and graph. It didn't show anything there. What I'm going to do is I'm going to come down here and press this and have it go down and do a 9. What does 9 stand for? 9 stands for stat. So since it's a statistic thing, I want it to do the stat zoom, and it should zoom it out that way. That's an interesting thing. That's not what I was asking it to do. I wasn't asking it for that kind of plot. I was asking for that kind of plot. Ah, there it goes. Now it changed to that. Thank you, sir. Now hit graph. And it should create zoom 9. There it is. Should create a histogram for me. So let's look at some of this. If I do a trace and put my, see how it's got the little cursor right here? It's showing my min's 14, my max is 21.6, and there's 2 items in that list. If I go to the next one, min's 21.6, max is 29.2, and there are 4 of them in that one. I created a histogram right here on my calculator. You see how that worked? You can play this back if you need to so that you can see how it works over and over again. But that's how you get histograms to work in on your calculator. Okay? So I'm going to move forward here a little bit more. We did that. Did that. All about relative frequencies. All about fractions. So that's what they're all about. I mean, when you're talking about relative frequencies, you're talking about fractions. I know. The F word in mathematics, fractions, but that's what it is, okay? So what percentage of the whole is each of these frequencies? If the value was 6 and it was frequency was 12, what is the relative frequency? The way you figure this out is you do a division. There's 71 total. This is going to be 12 out of 71. This one, my value was 7. There are 15 of them. That'd be 15 out of 71. You see what I'm doing there? I'm taking the total that's down here at the bottom and dividing each one of these frequencies by it, and that tells me that I have 12 71s in this one, 15 71s in that one. You know what? I don't do well with my 71s. Can't relate to that very well, okay? So I'm actually going to divide it on a calculator and see that I'm talking about what, 17% here? And if I take 15 and divide it by 71, I get 21%. Can you see how we could get that information off of what we have in this table? Can you see how I'm getting those percentages? Like I told you guys, 8th grade math, you could do this. Cool? Now, these type of things are called frequency charts. Frequency charts are where you're going to be using a lot of things in statistics because you're going to be looking at these frequency charts to determine, does this make a normal frequency? Is this a normal frequency? If it is, there's certain things we can say about it. That's what we're looking to get to, okay? Hopefully this has been helpful, and if you have any problems with it, feel free to give me a call. Number was on the first page of this first slide of the screens here. So look forward to seeing you in Class Connect later on this week. Bye.